All right, so today we are moving on to looking at some of those, some of the graphs that polars can do. So here we've got one called a spiral. So a spiral has this standard form, if you like. So r is, in this case, a half theta. So the radius will be some combination of theta in term for a spiral. So if we have a look at our coordinates, so our theta and our r, so when theta is 0, r is the half of that, which is still 0. When theta is pi on 2, r would be a half of that, which is pi on 4. When theta is pi, r is a half of that, pi on 2, and so on. So 3 pi on 2, half of that, is 3 pi on 4. And then go around the whole circle, 2 pi, and half of that is pi. So when we draw that, for example, here's our axes. And so we then need to think about what's going on here. And so when theta is 0, r is 0, so they've got a point there. So when theta, so when I go around here to pi on 2, then the radius out here is pi on 4. Then if theta was pi, then we've got a point out here at pi on 2 for the radius. Then when theta is 3 pi on 2 out of here, half of that's 3/4 pi, which is there somewhere. I haven't quite made my axis long enough. And then 2 pi, it's pi, and so that's there somewhere. Um, 3 pi on 4, 3 pi on 2. So what happens here is we get a line that goes around like so. Hence a spiral. So a bit wonky here in this bit of the spiral. There we go. Look at that, beautiful. So that's what we get. We get this spiral kind of shape. All right. So all our spirals, something times theta. All right, circles is the next one. So a circle with the radius centered at the origin, simply just r equals a. All right, so center here is the origin. Doesn't matter what your angle is, of course, it can be at any angle whatsoever, but as long as, so this one here, the inside one, r equals 2, doesn't matter what our angle is, we're at 2. So that's what doesn't need the angle bit, r equals a, and for the one with 5, there it is. All right, ones with the center elsewhere, it's a little bit more involved than simply that. So let's have a look at, so find the Cartesian equation of the curve with polar equation r equals 2 sine theta. So don't forget, of course, that r is the square root of x squared plus y squared. So that means that r squared would be x squared plus y squared. Don't forget that. Don't forget that x equals r cos theta and y equals r sine theta. All right. And if we rearrange that, sine theta is y on r. All right, so what we're going to do is we're going to use some of those things over in here. So r, we'll leave r as r for the moment, equals 2. Now sine theta I'm going to replace by y over r. And then what I'm going to do is I'm going to move this r here by multiplying both sides by r. And so now I have r squared equals 2y. Now I'm going to use this up here, that r squared is x squared plus y squared. And that equals 2y. And now I need to rearrange a bit. So let's bring the two y over there. If I take, got to take it away, don't we? Minus 2y equals 0 now. And what I'm going to do is complete the square with this stuff. The x is already a perfect square, but I want to complete the square with the y squared and the minus 2y. So that's y minus 1 all squared. Of course, we need a plus 1 there. We need a minus 1 there. All right, now what I'm going to do is move this minus 1 here across there by adding 1. And there we go. We've now got a Cartesian equation. And so this particular Cartesian equation, we should notice, is a circle. And its centre is at 0, 1. And its radius is equal to 1, because of course that's the radius squared. All right, so there's a circle not at the centre. So as you can see, the equation of that is quite different to this one where the circle, the centre is at the origin or on the pole. All right, so next, lines. Okay, so again, lines that go through the origin, through the pole there, it's pretty simple. So this straight line here that I've got makes an angle of pi on 6, and so simply can be expressed that theta is pi on 6. The radius, well, that doesn't matter. It could be anything as long as the angle that it's on is pi on 6. That's all that matters. All right. For lines not through the origin, then what we need to do is to get the polar equation, we need to convert our Cartesian. So here we use x equals r cos theta and y equals r sine theta to convert Cartesian to polar. So here's an example. Take a look at an example. So express x plus y equals 1 in polar form. So of course, remembering from what I've got just here, x equals r cos theta and y equals r sine theta. So we've got r cos theta plus r sine theta, and that equals 1. All right, so then you'll notice that r is a common factor, so I can take that out. And then if I divide both sides by this bracket here, I get that r equals 1 over cos theta plus sine theta. All right, and so that is the polar equation of this particular line here, x plus y is equal to 1. All right, so you choose an angle, and from that you then can calculate your radius of where your point is, how far from the pole at that particular angle. All right, now of course we can go back the other way as well. So express r equals 2 over 3 cos theta minus 4 sine theta in Cartesian form. All right, so what I'm going to start with is I'm going to start with that x is equal to r cos theta. So cos theta then is x on r. All right, so I'm going to replace that. I'm going to want to do the same here. And of course, that was y equals r sine theta. And so sine theta is y on r. And so I'm going to replace these two with what these expressions we've just found here. So the 2 is still there, the 3 is still there. Cos theta is x over r minus 4 times y over r. And you'll notice here, of course, we've got a common denominator here in each of those of r. So I can put that over. So I've got 3x there minus 4y, and it's all over r. Now, this on the bottom is a fraction. This line here can also be interpreted as divide, and as we know, when we divide fractions, we flip them and multiply. And so there we get that. All right, then what have we got? Let me neaten this up here. I've got r equals 2r over 3x minus 4y. All right, so we've got r that can go to itself once on that side and on that side. So we've now got 1 equals 2 over 3x minus 4y. And now if I multiply both sides by 3x minus 4y, whoa, don't want that, then I will get 3x plus, not minus, plus 4y, what am I talking about? Minus 4y, 3x minus 4y, and that equals 2. And so there is the Cartesian equation of that polar. And as you can see, this is a straight line. So as you can see, for straight lines, it's not as straightforward as for the circles, and the lines going through the origin. So yeah, and the spiral. This was the other one that I thought. So far more straightforward than straight lines, not through the origin. All right. So if there's anything in that you need clarifying, make sure you get it clarified. And as always, have fun.